Welcome to section 14.4, page 4. So go ahead and pause the video and do your classwork problems. And you can read the example and think about it, and even read over these definitions, and then turn the video back on. Okay, so hopefully you had a chance to do all that. We're still going to go ahead and read these things together. So how would we answer this type of question? Suppose that Megan scores 82 points on her math test. Okay, that sounds pretty good. Her twin sister scored 90. Whose score is better? Well, that's kind of relative. It kind of depends on how hard the test was, right? So that's the part that they give us some more information. They tell us on the 82, Megan scored 82. The mean was 63 with a standard deviation of 10. Whereas the 90 score came from a mean of 70 and a standard deviation of 12. So whose test score was more impressive? It's kind of a hard thing to answer the question. How can we compare these two? Well, the way we do it is with z-scores, okay? So when we take a look at the standard normal distribution, the z-scores are basically the number of standard deviations we are from the mean. So when we look at this, we keep saying that, we're 1, 2, 3, -1, -2, -3. So the negatives represent below the mean, the positive represent above the mean. So when you're thinking of test scores, the mean would be right here in the middle. So on this first one, it would be 63. The higher you get in this area, the better you scored on the exam, the more impressive it is. If you have a z-score of 3, that's a higher score, a better score than a z-score of 2. So that's what we're going to do. You're going to use these z-scores to compare. We'll calculate z-scores for both Kelly and Megan and figure out who did better. So how do we calculate a z-score? Well, we have to have a normal distribution. We have to know the mean and the standard deviation. So basically, don't look at this one. We're going to have data, and so this will be the score we use. So you're going to take your x, which is your data value. Here it says it's the data value. Then you're going to subtract the mean, and then you're going to divide by the standard deviation. So basically what that tells you is how many standard deviations you are. This z-score is, here it says, z-score represents the number of standard deviations a data point is away from the mean. Okay, so we're back to that problem again. Let's go ahead and do it by calculating z-scores. Okay, so calculate z-score. Okay, so let's do Megan first. Okay, so Megan's z-score. We say z equals x minus x bar over s. So in this case, what did she score? That's her actual data value. That's 82. Minus the mean. Her mean was 63. Divided by standard deviation of 10. Okay, so let's go ahead and calculate that. Be sure to do the numerator first or use parentheses. Okay, so we have 82 minus 63, that's 19. So 19 divided by 10 is going to give us 1.9. Okay, then we're going to go ahead and calculate Kelly's z-score. So what does she have? X minus x bar over s, or z equals. Her score was 90, minus the mean here was 70, divided by her s is 12. So here we get 20, again parentheses, or do the numerator first, divided by 12. What do we get when we do that? 20 divided by 12 equals 1.6666. Okay, 1.666 on forever. Z-scores are rounded to 2 decimal places. So here we didn't have to deal with it because it ended, but here we do. So we're going to say 1.67. Okay, so now when we think about who is better, being 1.9 standard deviations above the mean is better than 1.67 standard deviations above the mean. Let's draw a picture and see. Here, if we had our normal distribution, okay, and if here is our mean, that's a pretty lousy, let's straight line. But there's our z-scores. So when we're talking about z-scores now, we have a z-score of 0 in the middle because the mean would be right in the middle still. Then we go 1, 2, 3. 1, 2, 3. So this is a positive 3, this is a negative 3, and so forth. These are z-scores. So z-scores basically range from from negative 3 to positive 3. So where would we put them? Well, here's Megan. Megan is going to be here at 1.9. Okay, so this is Megan. Okay, at z equals 1.9. And let's do, I don't think I have a black pen in here anymore. We'll do a pencil. 1.67, so a little bit more than half. Let's do her, that's Kelly. Z-score at 1.67. So you can clearly see that Megan is above. Okay, Megan's z-score is higher. Now look at their actual scores. Megan scored 82 and Kelly scored 90. So even though Megan's score was higher number, or Kelly's score was a higher number of points, her z-score is lower, meaning she took an easier test than Megan did. So to answer the question, we're going to say Megan's score, I should say test score. Megan's test score was more impressive since her z-score is higher than Kelly's. Okay, and that's going to do it for us. That finishes this section, so go ahead and do your classwork and then your homework.